everybody. My name is Joshua Fernandez, and I work over at the West Campus in Doral. I've been working for Miami-Dade College for about 10 years now, and today I'm going to talk about Python. So my expertise is in computer science, and I'm currently in a master's program for computer science at FIU. And so today's presentation is basically going to be for beginners. People that already know how to code might not find this very useful, although you might learn a few things, and I will follow up with some deliverables that you can go through so that you can see some coding examples. Like I said before, this is going to be for beginners, so I'm going to go from the basic level so that you have an idea of what a program is, what Python is, and how to get started, regardless of your setup or what computer you have. So I'm going to go ahead and get started now. So let me go ahead and share my screen. The first thing I want to talk about is that if you are going to work in Python, the first thing you want to do is you actually want to install Python. So if you Google search Python, you'll come to their official website. It's python.org, and you'll want to download Python directly from them. So you can download Python by clicking here. If you're on a Mac, you will get the same kind of download, but you're going to get it the Mac OS version. And you can see that they have a bunch of other platforms and the different versions here. So that's the first thing you would want to do. You'll want to install Python onto your machine. The next thing you will want to do is you'll want to install an IDE. And an IDE is basically an integrated development environment. And it's just a place for you to be able to type up your code and also run it constantly so that you can check for errors and you can get some tips. There's a lot of IDEs available. Some of them are paid for, some of them are free. The one I would recommend is Pycharm. And that's just because in the Python courses that we've held here at the West Campus, I found that most students, especially students that are just beginning to code, really like this particular one because it gives you a lot of helpful hints as you're coding. And Pycharm is free. There is a private version, so the professional version you would actually have to pay for. It's a free trial, but they have a community version that you can download for free. So Pycharm is really good. If you look at some of the screenshots or you install it, it will be clear to how to use it. In the past, in workshops that I've done, I usually would do the installation, but I found that it takes a lot of time. So if you have any issues installing or you need like some tips on how to use use Pycharm or install Python, just write me. I'm going to share my contact info at the end of the presentation, and I'll be happy to field those questions individually. So the other thing I want to talk about before we sort of jump into some coding examples is what Python is and why people are currently using it. So Python is a multi-purpose programming language. It has become very, very popular because it is very easy to read and understand. So in the past, you would have to learn a lot more syntax and learn a lot about how a programming language works, but Python sort of has this appeal, especially for beginners, because it's very simplistic. Syntax for Python is very easy to understand. There's not a lot of letters. There's not a lot of stuff that you need to worry about as you're programming. Currently, Python is used for web development. It's used heavily for machine learning and data science. It's used for AI and automation. So a lot of people are utilizing Python, and many people that have coded for several years also are working on converting older programming language libraries to Python libraries because of the readability in Python. So Python is basically one of the programming languages that you should know if you're getting into development, and it's a nice one to start with. However, there's some downsides to starting with it, in my opinion. One of them being that if you move from let's say a more syntax heavy language, sort of like, let's say, if you start with Java or if you start with C++, and then you move from a syntax-heavy language like that one to Python, it's a little easier because you'll see that Python is much easier to write. But if you start with Python and then you move on to one of those languages, so if you go from Python to C++ or from Python to Java, Python to JavaScript, it can get a little confusing because all of a sudden you go from a language that has very little syntax to a language that has a lot of syntax, so a lot of curly braces, etc. However, that being said, it's still probably one of the most popular languages to start with because of its simplicity. So what I'm going to do now is I'm just going to jump into a live coding demonstration. So a lot of the code that I'm going to show is going to be shared afterwards, and I'll make sure to package it so that it can be shared with all the participants. And what I'd like to do is I want to just go over some stuff. I think that showing the code is easier than trying to just explain it lecture-wise. And if you see how it works, it's probably easier for you to grasp the concepts of Python. Okay, so I'm going to go ahead and get started on that. I'm going to use an online compiler, and the reason I'm going to use an online compiler is because I don't want to go through having to install any of the programs, and this is something you could also do. So if you have a computer that you can install programs on, you can come to this online GDB website, and you can actually compile your Python code, and you can write code right here on your browser. So I'm going to make this just a smidge bigger so everybody can read it easily. And the program that they actually start with here is the staple program for any type of programming language that you start with. It's the Hello World program. And Hello World is a basic way to see that when you write code, you can display output to a user. So if I run this, you'll see this down here in the console that there's a Hello World statement from this print statement. This is probably the most basic program. One thing to note here is that there's an inbuilt function within Python called print. So basically, within this function, anything that I put in here within quotation marks will print out to the console down here. So if I put, instead of hello world, if I put hello Josh, and I run this again, you'll see that now the console shows hello Josh instead of hello world. The print function is probably the inbuilt function in Python that you'll use the most, especially when you're getting started, because you'll want to see that your programs are working and that your logic for the programs is also working. So that's the very first one. The next thing I want to talk about is some variables and output. So I'm going to delete this print statement, and I'm going to talk about variables and output. So variables and output in other languages can get complex, but in Python, it's actually very simple. So for example, if I wanted to declare an integer, I can just say myInt, and I write it this way with the underscore because it's easier to read this, my_int. And when you declare a variable, you need to have it all connected. So your variable can't have spaces. So if you do this, you'll notice that it has this red thing because this is a keyword, but we'll get into that a little later. But basically, when you declare a variable name, you want to make sure that all of it is connected. So you can connect it with underscores, or you can do something like this. But for Python, a lot of people use this format, and they call this Pythonic format because it's very easy to read when you write it in this way. So if I say myInt is equal to 9, that is all I need to do to declare an integer in Python. So this integer now is going to be represented by this variable name. So what I mean by that is if I create a print statement and I write my_int, you're going to see that it's going to use whatever is equal here to represent this term. So I'm going to run it so you can see. So when I print and I have that variable name in myInt, you'll see that it prints 9 instead of printing myInt. Notice that I also don't have the quotation marks. For variables, you can just put them into print statements without the quotation marks. So myInt is, so 9 is equal to myInt, basically. and everywhere I use my int, now it's going to be represented by that number 9. Okay, so other types of variables that you can run, let's see, other types of variables that you can create are strings. So a string is basically a quotation mark variable. It's a text variable, if you will. So here it's Josh I'm using as my string, and this is going to have the same effect as the integer variable name that I have here. So let's say if I did the first statement like hello Josh, instead of printing it there, I'm going to go ahead and do my string, and it should print hello Josh. So there you see that it actually does that. And you can store these variables, the strings, and you can have these variable names so you can reference them later. So strings are another type. So another type is I'm going to call it my float. And floating numbers are basically numbers with decimal points. So this is helpful for calculations with money, calculations with percentages. So most of the types that you will declare that are floats are those types. And same thing, if I print my float here, it's going to be a representation of 9.9. Now that I've got these 3 different types listed here, so I have an integer that's called my int, I have a string called my string, and I have a float called my float. It would be a good point to mention that Python, unlike other programming languages, does not include a type inherently. So for instance, if you're used to, for example, C++ or Java, you would know that you would have to declare int my underscore int so that this would be an integer. But in Python, it actually infers the type. So it checks what you've equated the variable name to, and then it infers what type it is based on the information. But something that's helpful is that there's an inbuilt function called type. So if I write type and then I open some parentheses, you'll see that if I throw in my int value there, what's going to return here is not my integer, but it's going to return the type that my integer is, right? So here I'm going to run it, and you'll see that it says class int. So Python knows that my int is an integer. And by having it in this type function within parentheses, I returned what type this is. So the same thing goes for my other types here. So if I do my string, I'm going to go ahead and run it. And you'll see that it's str. So str is short for string in the Python language. Another thing I wanted to mention here is that you can name your variables anything. So I can name my variable s, right? So instead of having it called my string, I'm just going to call it s. And then when I call it s, it's going to go ahead and do the same thing. The type is a string. And if I take out this type declaration for the function, you'll see that it goes back to printing hello Josh. So that's a little bit about types and naming variables and what variables are. So there is one exception. The exception is you cannot name your variables reserve keywords. So there's a lot of reserved keywords. For example, one of the ones that we just used was type. So if I try to use the word type to name a variable, you'll see that this is a different color. And if I was in an IDE like Pycharm, it actually would give me an error once I type this. And the idea here is that you can't use a reserve word. So since type is reserved for the type function, you can't use that as a name for your variables. The same goes for things that we'll cover soon, which are other reserve keywords. For example, like you can't use the word str, you can't use the word int, you can't use the word float either. So there's a lot of reserved keywords, and this is important to note because you can name your variables almost anything, but there are some reserved keywords that you cannot use. All right, so going back to output, I want to combine these 3 variables that I've created into this print statement. And in Python, there's several ways to do this. There's single print methods. So a single print method would be something like this. So I print this, and then I print my string, and then I print my float. And then if I run this, you'll see that each one of my variables prints here, let me scroll up. It prints in my console. So on a new line, each prints. So 9 is my integer, hello Josh is my string, and 9.9 is my float. But let's say I wanted to combine these into a singular print statement. So you can do that, and there's several ways that you can actually do it. So one of the ways you can do it is by concatenating. And concatenating is a fancy way of stringing together things. So you're stringing together your variables here. So the way I can do that is I can just use the plus sign, but there's an exception here. So the exception is that in the print statement, so for this particular function, everything that you concatenate has to be a string. If it's not a string, then you will get an error. And because of that, we need to learn about one new thing. And the new thing that we need to learn about is casting. So when you have an integer and then you try to concatenate it, so let's say I have a statement here and I say, this is my integer. So I just write that as a print statement with my quotation marks, and then I try to concatenate it with the plus sign here. If I run this, it's going to give me an error. And you'll see that it will tell you what line it was. So it tells you it was on line 5, the error. So here's line 5. And then it'll say that this particular part of code, it has a type error. So Python can only concatenate strings, so strs, not int to strings. So the way you actually do this is you have to cast the integer as a string. And it sounds scary, but it's actually really easy. So in order to cast the integer as a string, or in other words, convert the integer to a string, all you have to do is use str. And when you do this, the str function is going to convert whatever is inside of the parentheses into a string. So if I run this again, you'll actually get, this is my integer, it's 9. So because they have these cast functions, you can actually cast most variables. Let's say you have an integer, you can cast it as a string. You can also cast an integer as a float, and vice versa. Even though if you cast a float as an integer, you lose whatever is in the decimal places. There's several casting functions, and I'm just going to list them really quick here. So the casting functions that you would use a lot is str. So this will change things to a string. You would use int to change something to an integer. You would use float to change something into a float, and you would use bool to change something to a Boolean value. So Boolean value is usually only true or false. So those are the two, these are the casting functions, but these are the two things that a Boolean value can become. All right, so let's go back now that we know what casting is, and I'm going to go back to trying to string together all of my variables here. So I'm going to say this is my integer, and I have my integer. So then I'm just going to add another plus sign with some quotation marks, and I'm going to say this is my string, and I'm going to say plus s. And finally, I'm going to say this is my float. And I'm going off the screen. This is my float. And I'm going to add my float. So the string I don't have to cast as anything, because as we saw before, here at the very beginning of my line, you know that my string, hello Josh, is actually a string. So there's no casting needed there. But for my float, I do need to cast this as a string. So I'm going to go ahead and cast this as a string. And then I'm going to run this so that we can see the output. So this is my integer, this is my string, hello Josh, and I forgot some spaces. So let me go ahead and add those spaces here and here. So here I have my statements. This is my integer, this is my string, hello Josh, and this is my float 9.9. So this is like a very basic example of how you can string together several variables. So when you make these print statements, you can actually have variables all tied together, and you can use them in your print statements to display information to a user. So That's one way that you can think about printing to a user. But another thing that you might be wondering about is how to get input from a user. And in a lot of coding languages, that can be a little complex, but in Python, it's actually really straightforward. So in Python, they have a special function, and the special function is called input. In input, you actually put a string inside of it to ask for information. So I'm going to ask the user for two particular things. I'm going to ask the user for their name. So I'm going to say enter your name. And then I'm going to ask the user to enter their age. So a few things to mention here would be the following. Input actually returns a string. And since input returns a string, often you will have to cast it as something else. The other thing that you need to know is that when you run this, the input is going to hold your program at each line that you declare it. So when I get to this line, it's going to display this message, enter your name, and it's going to hold there until the user actually inputs some information. So the other thing we can do here is we can declare a variable. So I'm going to say name is equal to the input of enter your name. So this will display when I run this code. And when it displays, whatever the user inputs is going to be stored in this variable, the variable name. I'm going to do the same thing for age. I'm going to store it in age. So here, if you notice, what will probably happen is someone will put their name for this first statement, and then they will put their age for this statement. But the age will probably be in the form of an integer. Because Python returns the input as a string, you have to be mindful of that, because if you try to do some kind of operation with the age, you won't be able to do it because it's going to return, whatever is returned here is going to be a string. So I'll show you what that means now. So let's say I wanted to print this information afterwards. I will just say hello, and I'm going to put plus name, and then I'm going to write you are, and plus age, years old. And I'm going to go ahead and run this. So when I run it, you'll see that in the console it says enter your name. So I'm going to go ahead and do my name, and then I'm going to enter my age. And you'll see that it says, hello, Joshua, you are 34 years old. And here you'll see that it stringed together Joshua and 34 years old. But let's say I wanted to calculate the age instead of just having the user input it. So I can do something like this. So let me go ahead and change here, and I'm going to put year of birth. And I'm going to say enter your birth year instead of that. And what I'd like to do is I want to take the current year minus the year of birth, and that should give me the person's age. So instead of displaying age here, I'm going to do 2021 minus year of birth. And if the function here works correctly, if my little formula works correctly, I should get the same age that I had before. But lo and behold, if I run this, you're going to get an error. So it doesn't give me an error at first, and it even lets me put in my birth year. So my birth year is 1986. But then actually when it runs this line of code, when it runs line 4, here you'll see that there's an error. And it goes to the same error as before. It says that I used an operator, so I used minus for an integer and a string. Remember that anything that you put in to the input is going to return as a string. So in order for me to actually have this calculation work, I'm going to have to declare or cast year of birth as an integer. So what this will do is it will take whatever the user inputted, and it will return an integer instead of a string, and then this calculation will work. So I'm going to go ahead and do this. I'm going to put in my birth year, and then here it still says that there's an error. So here it says that it has to concatenate a string. It can't concatenate an integer. So this is a different error from before. And it goes back to what I mentioned earlier. When you string or when you concatenate things together in a print statement, everything that you concatenate has to be a string. So this, what will happen in this calculation is an integer. Because it's an integer, it won't display. So I have to once again cast something, and this shows you how helpful casting is. And I could cast whatever is returned in this particular formula as a string. And now finally, this should work. So I'm going to go ahead and enter my name. I'm going to enter my birth year. And once again, it gives me, hello, Joshua, you are 35 years old. So my birthday actually hasn't passed yet, so that's why it says 35, and I initially entered 34. It's a minor detail, but no worries. So here you have this print statement, and you have an example of input. Just be mindful that if you use the input statement, remember that everything that comes out, so whatever is saved into the variable names, is going to be a string. So since it's going to be a string, if you're going to use your variables for some kind of formula like I did here, you have to be mindful that it's a string. So you'll have to first get a cast and change it to whatever variable type you want. And if you're going to concatenate it into a print statement, you want to once again cast whatever the formula returns as a string. So this is the basics for accepting input. The next thing I want to do is I actually want to do some looping, because looping is quite easy in Python, and it's something that is very helpful for you to understand in any programming language. So I'm going to go ahead and delete all of this. And unlike a lot of other programming languages, Python uses heavily the while loop. You can use it in a lot of programming languages, but in most programming languages for iterative functions, so for things that you're doing repetitively, they use the for loop. But in Python, a lot of the for loop has been replaced by the while loop. So I'm going to write a simple program that I want the user to give me a number. So when the user gives me a number, I want to loop through that number, and I want to just count up to that number. So the way I'm going to do that is I'm going to ask for that number first. So the number is going to be an input statement, and that's going to be enter a number, please. And that's going to give me a number. But because I want a number, what I'm going to do is I'm going to cast this input statement as an integer. So that's the first thing I'm going to do. So the integer here is going to cast whatever is inputted. So whatever is from the input statement is going to be a string, and then it's going to cast it as a integer, and then I know that whatever is in number is actually going to be a integer from the get-go. So the next thing I want to do is I'm going to declare a while loop. So the first thing I want to go through is what the syntax for a while loop is. So when you write a while loop, you have to use this reserved word while, and you're going to have two parentheses. Within this parentheses, you actually have to perform a test of some sort. So for right now, we're just going to write true. And then the other part of the syntax is you're going to do a colon. And in the next line, you need to have a tab. Notice where my cursor is. If you don't have that tab, Python won't know that this is the block of code that the while loop is going to perform. In Python, there's no curly braces, so everything needs to be done with these tabs. So it's either 4 spaces or an actual tab by hitting the tab key. So this is the syntax, but what I wanted to go over is this. Basically, while the statement in this parentheses is true, the while loop will continue forever, right? So if I put while true, it will just continue forever. And since most things you don't want computers to do forever, you need to put some kind of statement that will stop the while loop from running. So the first thing I want to do before I actually create a statement is I'm going to create another variable. And that variable, I'm going to call it I. And I is our iterator. It's going to go through all the routine repetitions of what we're going to do in this loop. So I'm going to set it equal to 1 to begin with. So when I is equal to 1, I have the user input some number, And then what I want to do for the condition is while I is less than the number that are inputted. So here, what we're actually saying is while 1 is less than whatever number the user inputted. And all I want to do here is I'm going to say print I. I want to print whatever I is. And then the last step for this to work is I want to increment I. So the actual, what is actually happening here is this, is I is equal to I plus 1. So in the first round, while this goes through and then it gets to this line of code, it's going to say 1 is equal to 1 plus 1. And then that means that I will be 2. So we're changing I in this last step so that it increments by 1. Another way you can write this, and this is probably the most common way, is I plus equals 1. And in this particular way, it's a little shorter, but it's the same idea. You want to take whatever is saved in saved in I, and you want to increment it by 1. So if I run this program now, you'll see that it asks me for a number, and let's say I put 10. And you'll see that it actually counts from 1, 2, 3, 4, 5, 6, 7, 8, 9. And it stops at 9. It doesn't get to 10. And the reason is once I is 10, 10 is not less than 10, right? Because if I inputted the number 10, once I is 10, 10 is not less than 10. It's actually equal to. So one way I can change the condition in this test is by doing less than or equal to. And now if I rerun this, you'll see that if I use the same number, it's going to give me 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the magic of looping is that I only did this for counting, right? So it's a very basic operation, but I could input any number. So let's say in the number I put 10,000. This will actually count to 10,000 relatively easy for me, and I could copy and paste this, or I can use this for some kind of program, or if I had to go through 10,000 records, I can actually sort through all of them and go through all of them very easily and quickly. And this is one of the things that makes coding so powerful, and a lot of this is used for implementing things like AI and machine learning, because a computer can sort through millions of records in record time versus a human that would take a long time to do it. And looping is one of the tools that we use for coding that makes that possible. So this is a very basic program that allows you to print these numbers. And I wanted to share this particular example. So I have one more example, and then I'm going to share some resources that I think are particularly invaluable for anybody learning to code. But before I do that, I wanted to talk about one last thing. And the last thing I wanted to talk about is the modules that Python has. So modules are very much like libraries from other from other programming languages. So since Python has been around for a while now, there's a ton of modules that have been pre-written to help you write code. So for instance, I can declare here at the top, import random. And when I do that, I'm actually importing a module. I'm importing the random module. And when I do that, what I'd like to do with the random module is I'd like to go ahead and generate some random numbers. So here, I'm going to write a statement. I'm just going to say print, and I'm going to say here is a number between 1 and 10. And I'm going to go ahead, and once I've done that, I'm going to say plus str, since I'm going to have to cast this to a string. And then I'm going to call random.randint, and I'm going to set a range within here. So I'm going to say 1 and 10. So this random.randint is an imported function from a module, the random module. And if I run this, you'll see that it gives me a random number between 1 and 10. It gives me 5. And if I run it again, it gives me another random number. And if I continue to run it, it just gives me random numbers over and over again, only within the range of 1 to 10. So obviously, since I have a short range, it's only between 1 and 10. Sometimes the numbers repeat, but you can see that it is truly random. And this is only one of the modules, and this is probably the easiest one to wrap your head around. because all you have to do is import it, and then once you've imported it, you can call these random functions, so random int, and you give a range. So this is the low end and this is the high end. And I casted it as a string only so that I can just print it easily. But the modules are really powerful because you can utilize them in order to make your code easier to program. So instead of having to program something from scratch that will generate random integers, you can just import this random module, and then you can just use a simple syntax like random.randint to do this if your code, whatever you're working on, actually calls for you to create these random integers. So that's it for my live coding demo. I wanted to save some space. I'm not sure that there's very many people, but if anybody has a question, you can go ahead and ask now, and I'll try to answer from what I did. And then after that, I'm going to go ahead and change so that I can talk about some resources quickly.
Hi, Josh. I don't see any questions on the chat right now.
So I'm going to go ahead and I'm going to do some quick resources that I highly recommend that you check out if you're interested in coding. And I break it up into 3 things. So the first thing I'd like to talk about is a website that is probably very familiar to people that have coded before. But if you're just getting started, if you go to this website, w3schools.com, they have a complete breakdown of tons of different programming languages. They have web development, they have application development, encryption stuff, a bunch of things that are here. They do offer some paid courses, but the vast majority of the things that are available here through W3 Schools is free. So they have a whole Python section, and it's great because they break down everything by what it is, and they give you examples, and then you can actually do some practice by doing the practice sets that they have here. The other thing that you can do is at the very end here, they actually have examples, and I think the examples are great, especially once you start to get a hang of what programming is, and if you start to get a hang of Python specifically, you can always come to the examples and just see examples of the things that you could create with Python. So this is a great resource. It's free, and I highly recommend it. So the way I recommend this is if you're looking for something to learn, you're looking for it as a textbook, if you will, this is a great resource for all sorts of programming languages, but specifically for Python, it's great, and I highly recommend this one. I break up the resources in 3 parts. So this one is really just a true and tried resource. So if you have a question about something, or if you're just wanting to learn something different about Python, you can come here and find the resource. But the other thing that I like to recommend is practice. So the other website I would recommend for practice is Code Wars. So Code Wars is specific because they actually give you problems that are similar to the problems that you will face when you actually start to code. Once you make an account, it's free, by the way. They have this kata breakdown of exercises, and they set it up by difficulty. They set it up 8 is the easiest, and 1 is the hardest. So it actually goes backwards. It goes the higher the number, the easier the problem. And you can actually do it by language. So they have a ton of languages, but then if you just select, for example, Python, you get tons of programming challenges that are specific to the Python programming language. So for example, I'm just going to go ahead and choose this return negative, and I'm going to click on the symbol that is Python, and this is the Python. It's like 2 snakes. And you'll see that the exercise is basically they give you a prompt. Is this simple? In this simple assignment, you are given a number and have to make it negative. But maybe the number is already negative. So it tells you what you have to do, and as you code it here, you can attempt to find the answer. And if you get it right, they give you points, and then they also show you different answers from other people. So not only can you practice your own coding, but you can see the perspective of other people that are doing these same coding practices. So this is great for practice. And much like mathematics, for you to get better at coding, you do need to practice. You need to spend some time, hopefully daily, just doing little by little so that you can feel that you're understanding what's going on in Python. All right, so the last thing I'd like to show is two websites. One is called Geeks for Geeks, and the other one is Stack Overflow. These websites are great for specific inquiries. And what I mean by that is that if you have a question that's very specific, like you're working with lists for the first time in Python, or you're working with a database in Python, you could come to these websites, which both of them are free, and search for specific questions. So like, how do I reverse a list in Python would be a good example. And I'm just using Stack Overflow, so I'm not a robot. And you'll see that there's 353 results. So how to reverse a part of a list, reverse order of lists, how do I reverse a list using recursion. So when you actually are working on specific things in your programs, these websites are great for those inquiries that are very specific. There's other websites like these, but I have found Stack Overflow and Geeks for Geeks to be immensely helpful. And you can see that there's just a huge community of people. For example, there's tons of votes for these particular queries. And like, let's say this one. Actually, this one doesn't even have anything to do with what I searched. So let me go for this one. How do I reverse a part slice of a list? And you'll see that some of them are much older. So this is 10 years they asked this question, but it had 7 answers, and people upvote or downvote the answers, and they actually give you code examples to do so. They're great resources. I highly recommend that you check them out and that you use them so that you can go further along with your coding studying. So the last thing I want to do is I want to show you my contact info. So if you come to the main page of the college, you can find my contact info under academics here. Then if you go to libraries, and then you want to go to contact, and I'm available over at the West Campus, and you'll find my position here, my phone number, my room number, and my email. Feel free to reach out to me either by phone or by email. I'm pretty good about answering emails in about 24 hours. And if you ever need any assistance with coding, or you just want to have a conversation about languages or conversations about how to implement things, please reach out. I'd be happy to converse with you. I'd be happy to help you. So that's it for my presentation. I'm going to leave this up for just another minute. And I want to thank everybody for watching this, and also for those of you that attended. I appreciate your attention. Have a great day.